To begin with, let's take a look at a diagram of the experiment. One moment. Here we are. So the experiment begins with the pump laser, shown here. Light from the pump laser bounces off of two mirrors. It goes through some optics, in particular, a polarization rotator, and then it goes to the down conversion crystal. And after that, the violet beam from the pump laser is blocked. At the down conversion crystal, though, we create two new beams. These beams are each at 1/2 the photon energy of the pump laser, so the wavelength is double. Instead of being 405 nanometers, they're each at 810 nanometers. Two red photons are created from one blue photon. The photons travel in slightly different directions. One travels along this beam, which I'll call the gate beam, or the idler beam. And the second goes to over to here. We'll call this the signal beam. The gate beam proceeds through a polarization rotator, which we can use to adjust the polarization, and then if we like, to a polarizing beam splitter, and then to a fiber coupler. The fiber coupler couples any light, any photons, onto an optical fiber, which goes to a single photon counting module in this box. The signal beam looks very similar. Signal photons would travel along this path until they reach and go through a polarization rotator until they reach a polarizing beam splitter. At the polarizing beam splitter, they might be transmitted or reflected. If they're transmitted, they go to the transmit fiber coupler, proceed along a fiber, and go to a second photon counting module, while if they're reflected, they likewise go to a third photon counting module. So that's the basic setup. Okay? Here, one second.